Hi, Aspen. This is Mr. Lonnie, and I'm going to videotape a solution for you. Two different ways. This is for the binomial probability distribution. So we have you have the correct requirements here, and we can recognize this problem in the assignment 5.3 as binomial distribution because it fits all that criteria. So we have, if 12 wolves were spotted in this region from a helicopter, what is the probability of that? And I'll do part B, 6 or more were female. Okay, so in this problem, N is going to be 12, since the 12 wolves represent N independent trials. In other words, they're independent because, if one was a female, it wouldn't have any effect on the other one being a female, or male or whatever. So we're going to assume there's 12 independent trials where P, you could choose either one. You could say the probability of success is 0.7 if we were talking about males, or the probability of success is 0.3 if we're talking about females. So since this part B asks 6 or more were female, I'm going to use P equal to 0.3. And then R is going to be, well, we're interested in 6 or more. So it could have been 6, could be 7, could be 8, could be 9, 10, 11, or 12. Okay, but we're not interested in the probability 0, 1, 2, 3, 4, 5, right? So we know that the entire sample space adds up to 1, all those probabilities, but we're going to throw out 0, 1, 2, 3, 4, 5. So I'm gonna do this two ways. I did it one way here on paper. Let me show you. Oops. Let's go ahead and get this up here. Okay. So on this one, just using the binomial distribution formula, where I have n factorial over r factorial times n minus r factorial, and then p to the n minus r and q. Q is 1 minus p. So if I use 0.3 as p, I'll be using 0.7 as q, or 1 minus p. Okay. And so I can find the probability that exactly 6, well, that's 0.079. So that would be the probability that exactly 6 were female. But it could be 6, or it could be 7, or it could be 8, or it could be 9. So since I'm saying or, 6 or more, I'll be adding those probabilities. And I could go on like this, figuring out the probability of 6, figuring out the probability of 7, figuring out the probability of 8, etc., and just do the same thing, applying it in the formula, and then add those all up, and I get 0.1178. I also wanted to show you this on the calculator, on the TI-84, because it's handy if you have one there. We can go to second distributions. Actually, you know what? I'm going to do this a different way. I'm going to say 1 minus, and then I'll go second distributions, and I'll scroll up here where it says binomial CDF, cumulative distribution function. Now the CDF will put in the probabilities add up to whatever I put in here. So I'm going to go 12, comma, that's my N, my number of trials. 0.3 is my probability of success on any individual trial. So in other words, there's a 30% chance that any one of those wolves is female. And then here, this CDF function, cumulative distribution function, will add up to whatever number I put here. So if I put 5, basically this is going to add up all the probabilities 0, 1, 2, 3, 4, 5. And then if I subtract that from 1, I'm left with 6, 7, 8, 9, 10, which I did manually. It came out to 0.1178. So, yeah, and so I get the same thing here. Now, I could have also done each one individually, like I could go, oops, if I use the, let's say I just wanted to know exactly 6 were females, okay, which I've got figured out up here manually. I could go to the binomial PDF. This does not add up anything. It just gives me the exact whatever I put in, for my R in the last here. So I got N is still 12. 0.3 is the probability that I'm going to see, and I put a comma between these, then I'll say 6. So this is going to give me the probability that exactly 6 were female. And I get 0.079, same thing I got here doing it manually. So, and I could find out 7, 8, 9, 10, and I could add them all up. And when I add them all up, I'm going to get about 11 or 12%. If you rounded this, it'd be about 12%. Okay, so I hope that helps you a little bit. This is a good thing to know. These the TI-84 is made for this class. It has all the functions in there, the probability, binomial, the Poisson, all of them. So it's a good idea to look over some of those videos I've been making and try and get versed on using the TI-84. Okay, I hope that helps, Aspen.